All right. So lesson three is going to be special right triangles. Okay. With these ones, again, you could still do Pythagorean's theorem to solve it. However, if there are going to be these special triangles where you either see a 45 degree angle, a 45 degree angle, and a 90 degree angle, you do not have to do all those extra steps to get to do Pythagorean theorem to figure out the hypotenuse or one of the other sides. Same thing if you have a 30 degree, 60 degree, and 90 degree triangle. Again, these two types of triangles have a quick little shortcut that you can use to get your final answer really quick. So the first type of triangle I'm going to look at that we'll have is going to be this 45, 45, 90. Again, all of these are 90 degree triangles or right triangles. When you have a 45 degree triangle, so this side over here, so let's say this would be like a 5. I'll say that's 45 degrees, 45 degrees. So 45 degrees, 45 degrees. Again, they gave you this formula up here of L. So it says L, and then the hypotenuse is going to be L times radical 2. So if I have this shape over here, again, it was triangle had L, and then L radical 2. So if these ones are both 5s, I don't have to do Pythagorean's theorem. I don't have to try to do all these extra steps. I got 5, I got a 5. So my hypotenuse for this one is going to be that exact same number, and then I just get to add the radical 2 onto it. Okay, if I were to do all those steps, okay, and I'm going to show you why it works using that 5 that I just put there. Because again, if I did Pythagorean's theorem, I'd have 5 squared plus 5 squared equals c squared, because I don't know the hypotenuse. Well, I've got 25 plus 25 equals c squared. I get 50 equals c squared. If I'm going to square root both sides, well, I know I can break this one into 25 times 2. And this one equals still, again, radical c squared. This 5 gets to go on the outside, so I get 5 radical 2, and that equals that c. Again, I could do it with Pythagorean's theorem, but if I use this shortcut, I don't even have to, I don't have to think. I just get to write this number here and just put it right there. Does that make sense? Feeling good? So we'll have a couple examples on this one, and then I'll show you the other one. So my very first, I'll jump to here first. My first example here, I've got this triangle. There's a right angle here, there's a 45 degree angle there. This one says 9, this one says x, and that's what we want to solve for the x. If this angle is 45, what's this one have to be? 45, because he's adds up to 180 every time. So that one's going to be 45. If this angle's 9, or sorry, this side is 9, what's this side? It's the same thing. Yeah, it's 9. So again, I'm just going to write this stuff in. You don't have to do it every time, but I'm going to just, because I want to be redundant. Again, it's a 45, 45, 90. My sides that I have are going to be 9, a 9, and I need to find the hypotenuse. I can use that really quick and easy rule and just say, again, this side over here is going to be L times radical 2. So the length of x would just be 9 radical 2. And that's it. I'm just taking whatever this number is here, and then I'm multiplying it by radical 2. And that's it. So far, so good? I'm going to give you the one tricky one here.
We have a question.
Yes, ma'am.
We have to so we just do 9 radical 2. We don't do.
Don't even do it as a decimal. Yep, you're good. Just write it as 9 radical 2. Yeah, if you have the 30, 60, 90s and then 45, 45, 90s, you'll never have to do the sine, cosine, tangent because you'll have all the numbers there. Okay, this triangle here, again, it doesn't tell me the angles, but are these two the exact same measure? If they're the exact same measure, that means that this angle and this angle are the exact same measure, which also means that they're 45 degrees. Again, if these two sides are the exact same, it means those opposite angles are going to be 45 degrees each. So to find the length of this one, I'm going to take this number, so 6 radical 2, and then I'm also going to add a radical 2 with it. Because again, what we had every single time, I'm going to write the 4590 on there, was the L times radical 2. So my L value for this one was 6 radical 2 times a radical 2. If I've got two radicals together, what happens to those? What's radical 2 times radical 2? Radical 4. So I got 6 radical 4, or 6 times the square root of 4. Do you know the square root of 4? What is it? 2. I've got 6 times 2, meaning that the length of this one is going to be 12. Again, if it's already inside of a radical, these ones get to multiply by each other. Feeling okay-ish? Okay, I want to see what you guys can do then. There it is. Oh. Yeah. Actually, I'm going to do one with you, and then I'll go back. Do this one by yourself. That's the one I wanted to do. We are going to do the other one. Just do this one by yourself. So that 5 radical is the hypotenuse side. This is the long side. That's like this one. So I just want to get rid of that radical. Okay.
Yeah.
All right.
I mean, I have an answer, but I think it's right.
All right. So tell you what, I got a lot of confused faces, so I'll do this one with you. Yep. So again, when I have this formula here, to find it, I know that this side here will be my L, my length. To find the hypotenuse side, it is L times radical 2. You see how this one has a radical 2 already? Those ones are going to cancel each other out, and that's all that's left over. It's just that 5. So again, if I'm trying to solve this one, let me get a different color pen. And I use those same formulas. I got L, and then an L, and then an L radical 2. Putting them directly on top of each other, I know that these ones will cancel out. And my L value is only going to be that.
Okay, so why didn't that happen on the other one we did?
Because those ones were on the outside.
Okay.
Because this is the L value here. So the L value here, L value here. And I'm just doing the L times 2.
Okay.
Times radical 2. Again, L value there. L value there. Times the radical 2. So again, these ones are if they give you the legs. If they give you the legs, you're just going to add the regular 2. If they give you the hypotenuse, you just have to get rid of the radical 2. Okay? This one, I'm going to do this one with you. Because again, I don't have a radical 2 that's with it right away. So I want to show you that part. Okay. So, again, this one's going to be the X down there. I don't know it. This one's still going to be 45. I'm not too concerned with that. Excuse me. What I'm going to do, looking at this one, is I want to try to figure out how I can take out a radical 2. Okay? So for me to take out a radical 2, what I can do is I'm going to change this one into a kind of a mixed radical and a whole number thing. Okay? I can take this number, whatever that number is. I'm going to show you the steps. I'm going to say 18, and I want to divide that by 2. And hopefully it'll make sense in a second. If I take 18 and divide it by 2, I know that half of that is going to be 9. And if I want to put it back together, it is the same as saying 9 times radical 4. Because it was 9 times 2, right? Hopefully. The square root of 4 is 2. So again, I'm just going to divide it by 2, and then whatever I had left over, I put it as a radical 4. If I really wanted to get picky here, because I only want to get rid of that radical 2, how can I rewrite radical 4 using a square root 2? Any thoughts? I'll help. So I got 9 times radical 2 times radical 2. Does that kind of make sense on how I got there? So again, I divided it by 2 so that way I could get a whole number and then I could get a radical number. I'm just trying to get a radical 2 all by itself inside of there. So the rule was, for this one, let me get a different color pen. The rule was, for the hypotenuse, it is L times radical 2. So L times radical 2. I can get rid of one of those radical 2's. What's left over for the length of that side? I'll cover it up and you guys can tell me again. What's left over for my length of L? The only thing that's not covered up.
18.
Nine radical
9 radical 2.
Oh,
So the only thing that's left off over here for the L is going to be 9 radical 2. So I got 9 radical 2 there. My value for x right there is going to be 9 radical 2. Again, this one this part getting gets a little bit tricky if they don't give you a radical. Just remember, I'm going to give you this trick. Divide it by 2 so that way you can make that top one into and that radical 2 times radical 2 so you can cancel it out. You'll see one of those ones. Questions on that one? Okay, thumbs up, thumbs down, or like right in the middle, you're completely lost. Okay, as long as I got a little bit above that, I'll work with it. Okay, if you were still struggling with it, I will help you when we start the assignment, and I want to make sure I help you during class time. Okay, so that way you're not going through without it. So that was the 45, 45, 90. I'll write that here. That was the 45, 45, 90. My last special type of triangle is going to be the 30, 60, 90. Okay, this one I'm going to use S's instead of L's to describe it. But for my 30, 60, 90, that's what this one's called. So the angle that is opposite of the 30, I'm going to point and show that stuff. The angle that's opposite, or the side that is opposite angle 30, we'll use and just call it S. Meaning it's just the side. If you can figure out this side, the one that's opposite of the 30 degrees, the hypotenuse will be 2 times the S. The other leg, one opposite of 60, will be S times radical 3. Again, if I wanted to go through and when we choose some numbers, I can show you with Pythagorean's theorem, but it'll always work out this way. And I'll leave this one on the board. It's on the notes as well. But again, if you can find the one that is opposite of 30 degrees, that will be the letter that we get to use for the remaining 2 sides. So the goal for you, try to figure out this side, and the other 2 will fall into place really easily. Okay? Anybody need more time with the picture? Okay, we'll do a couple, and then you'll be on your way. So, for this one, I don't want to start with the hard one yet. Just kidding. For this one, we're going to start with the not hard one yet. I've got the right angle, 60. That means this one on top has to be 30 degrees. I'm just going to write those. You can write the triangle down first. Okay, for this triangle, what side are they giving me? Like using these formula, are they giving me the S side, the S times radical 3 side, or the S times radical S, or sorry, S times 5. Sorry, 2 times S, I can't talk. They're giving me the 2 times S side. This side is the 2 times S. I'll make it a big S so I don't confuse it with a 5. Because they look the same to me. So if this is 2 times S, any thoughts on how I can figure out what S equals? What's that? Yeah, if I wanted to do algebra, I could say 2S equals 10. How do I get S by itself? Divide both sides by 2. Which tells me that S is going to equal 5. Okay, of these sides, which one is going to be the 5? The X or the Y? Okay, good guess. I want to look straight across from the 30. So straight across from the 30, I'll do this. And this one is straight across from the 60. So I want to look straight across from the 30 to find my S. So X is going to equal 5. To find the other leg, I'm just going to put that same number. So the 5 times radical 3. So for Y, I'm going to have 5 radical 3. Okay? Did that make sense on where those numbers came from? Again, I tried to solve for the S. And as soon as I did that, that number goes into it. I can double check. This is 5. This is 2 times 5. This is 5 times radical 3. All right, I'm going to go over to the trickier one. Okay, so I'm going to do the exact same thing that we kind of did before, and I'm just going to give those letters and the formulas on what they should be. So the one that is opposite the 30, this X is going to be my S value. This Y is going to be my 2 times the S value. And that means this one is going to be my S times radical 3 value. Okay, I'm going to do the way kind of Ricky talked about if I just set them equal to each other. So let me grab a different color pen. So Ricky just said I should just make S times radical 3 equal whatever that other number is. So equals 12. All right. So I know this is going to be a radical 3. So I got to see if I can break my 12 side down into something that has a 3 in it. So I can rewrite this one. So again, S times radical 3. I'm going to break my 12 apart into smaller sections. So 12 times 3 is going to be the same as saying 4 times 3, right? I'm going to do one extra step here. So again, I still have S radical 3 equals 4 times radical 3 times radical 3. If we have 2 of these, and I want to put them into a square root, these can kind of break apart. Because radical 3 times radical 3 equals a 3. If you want the extra step, I'll show it in red. Whoops, what happened? So I'm going to show it in red here. Sorry about that. This 3 turns into radical 9. And then from that radical 9, that's how I broke it apart into those. Okay, so I've got this S radical 3 equals 4 times radical 3 divided by, or times radical 3. I'm going to divide it by this number here. So these ones will cancel out. I want to divide this one by radical 3. These ones cancel out. So what's left is going to be my S value. My S value equals 4 times radical 3. Again, that part got canceled out. That part got canceled out. And I've got S equals 4 radical 3. And now I can just plug those ones back in. So my S value for X, that one is going to equal 4 radical 3. For my Y value, I'm going to say 2 times 4 radical 3, which is 8 radical 3. Again, setting them so that way they're equal to each other. I like how you put that one. Makes it real, it kind of turns it algebraic and it makes it a little bit easier. Hopefully. Do those steps make sense? I want you to try one on your own. I'm giving you perfect. Nice job. What was this actual answer you got? Yeah. Yeah, this one, right? That's your answer. So you're just gonna plug this value here into that equation. Yep, that's it. Yeah, so this is good enough for an answer. That's it. You got it. Thank you. That's what I would have Yeah. That's it. On the other side. Okay, so that's your S value, right? We're just gonna plug in this number anytime you have the S. This is gonna be 2 times the S value. So what's the S value? 72 times 21. What does that mean? That's it.
Oh, so all I have to do is,
Plug it back in.
so I don't have to.
So that was if they gave you one of these other sides. If they gave you one of these other sides, you had to do those extra steps. This one, they just give you the S value, so you're just gonna plug it back in. Okay. A lot of you guys were doing this, and I'm just gonna write the same things that most of you guys were doing. This value down here was your S value. The one on this side was going to be S times radical 3. And the one over here was going to be 2 times your S value. Because you already had your S value to solve X, you were just going to take 2. And instead of writing S, you're going to plug this number into it. So 2 times 21. So your x value should have equaled 42. On this one, you're just going to plug this s value over here. You should have 21 radical 3. And that's all I was looking for the y. So your y value is this. And then your x value is that. All right. Very last part. I'm just kidding. Very last thing I had is the assignment. 8 through 22 even. Okay. The first part will be dealing mainly with the 45, 45, 90s. And then the next part will be the 30, 60, 90s.